Good day, everybody, and welcome to this, what is a re-recording of the last webinar. We're re-recording it due to some audio problem we had the last time. I'm Denis Gagné, CEO and CTO of Retake.
And I am Tom Devivoise, CTO and CEO of Knowledge Worker Copilot.
So today, Tom and I are going to discuss why an orchestrated AI architecture wins every time in a regulated and mission-critical environment. So enterprise AI is now a governance problem. We will show you what a control enterprise AI architecture looks like with observable behaviors, case created, email drafted, global context captured and understood, process invoked, and human approval step all visible. Let's start with a quick demo of what we're talking about here.
Use the Knowledge Worker Copilot to initiate a loan affordability request for Ima Keller. We are currently in the Google Workspace account for our underwriter, Pat. This demonstration will showcase the capabilities of the Knowledge Worker Copilot agent. First, the Copilot will create labels for the borrower and the related data request. Emails related to Ima will be assigned these labels. The Copilot agent will add the borrower's contact information, set a suspense date for the request on the calendar, and manage other relevant details. The Copilot also provides a dashboard that reflects the progress of the pre-authorization workflow. Next, we navigate to the Copilot agent helper within the Google Workspace chat. We launch the agent by submitting a request to initiate the pre-authorization case, including the borrower's contact information, the requested loan amount, the down payment, and the purchase area zip code. The zip code is necessary for the agent to estimate the insurance and taxes for the requested mortgage. After several minutes, the pre-authorization agent starts successfully. Labels have been created for Ima, and the agent has created the contact and added a suspense date to the calendar. The Copilot dashboard also reflects the workflow status, which is currently set to draft. Pat reviews the drafts and sends an email to Ima. The Copilot has added the played label to the sent email, and the dashboard now indicates that the request has been made. Now we're going to show Ima's email account. Ima opens the email from Pat, which contains a link to the played authorization website. She clicks on that link and completes the authentication steps. In this instance, we are using the played sandbox. The actual process involves logging into the selected banks and granting played access to her account information. Once she confirms the access, the information is forwarded back to the agent. After several minutes, the account information is combined with the requested mortgage amount. The bank then estimates a mortgage payment, applies the Fannie Mae ability to repay pre-authorization rules, and forwards the information to Pat, the underwriter. Ima will receive an email acknowledging her authorization. When we return to Pat, the underwriter workspace account, we see an email from the Copilot containing the results of the mortgage pre-authorization evaluation and a thinking AI evaluation of the data. The dashboard also reflects that Ima has completed the authorization. Pat, at this point, can issue a letter of credit to Ima, or she could ask Ima to make an adjustment to her pre-authorization request. Additionally, we can request the Knowledge Worker Copilot agent to summarize the status and outcome of the pre-authorization for Ima. Okay.
So that was our demo. Now let's discuss about everything of what you've seen.
Okay. So the demonstration we just observed shows that the agents that we're generating, if you want to call them that, operate with an architecture that is using versioned actions. Everything that was done can be traced back to the original request and how the various parties responded to that event. So each action is governed by a model, whether it's a deterministic BPMN, CMNN, or DMN, decision model notation. Those actions are not just a series or a chain of large language model prompts. The prompts are inside of basically the process model nodes, and they're managed and versioned within the overall process. So that architecture, which we're going to go into depth on, provides and assures full traceability. Next. So the consider any enterprise or your organization's processes as an iceberg, right? The systems we have currently in place that handle the visible top level system of record transactions, like ERP, supply chain management, customer relation management, Salesforce, and so forth. It addresses those transaction oriented processes. They are all well documented, very mature, and they work very well. But the knowledge worker copilot addresses the work that happens below the waterline, where the human interactions typically take place. Above the waterline, those system of records have structured software packages, and we rely on them daily. But that real work that we're describing below the surface here is what we call shadow processes. And that is really manual task, pivot chair pivoting, swivel chair integration, contract administration, complex sales, any type of process that requires a lot of expertise, understanding, and knowledge and context in order to execute that. So ultimately, the knowledge worker copilot has been designed to handle those activities below the C line where human engagement is essential, if not mandatory. These are the tasks that AI is attempting to automate and digitize, and that's the problem we're trying to solve here.
And I guess what you're saying, Tom, is that
Yes.
all this AI that is involved there is there more as an augmentation to the people that still have the end decision to take and control.
Yes, the essential nature of the human judgment never gets eliminated here. We never have AI, even the most complex expertise AI, make a judgment and take an action. We use that to inform our knowledge worker of what the situation they're observing. So while, and just about all I wouldn't say that all of the agentic software tools that we see are trying to automate these unstructured workflows. But what we've observed is the rise of autonomous agents have inadvertently birthed this shadow process that is escalating system risk. Then we've heard more and more stories about that. So current solutions really are not solving the swivel chair problem. They're creating fragmented, we call them like situational agents, where and you've got a lot of manual data handling loops that really don't have very deep integration. So without a robust governance framework, those unstructured agents create decentralized important decision making moving, right? So I have seen numerous examples of business rules that were incorporated into the agentic examples. For instance, if the memo is more than $10,000, route that this way, right? That information, those rules should be in the architecture that we're describing today, not in the prompt that you're entering. So we need organizational oversight on the stuff that they're creating. And those point-to-point architectures are kind of brittle and unsafe prompts beyond that enterprise control, rather than the structure, enterprise-grade guardrails that we're proposing here. Next.
So generally speaking, there are three basic approach of leveraging AI. One is to be prompt-centric. And when you're in a prompt-centric type of AI, that's what most people are familiar with. You basically control the prompt and you control what goes into the prompt. But unfortunately, the behavior is completely implicit. You don't have direct view of what's going on. So you have this black box AI that is really hard to audit or figure out what's really going on because you don't have visibility. And if you scale that to a large amount of work, then there's a lot of intervention that you'll basically, and you're scaling chaos fundamentally. Another approach, which is mostly being deployed now, is this integration-led AI, where you have all these API calls that are going on and bringing this infrastructure. Now, there's no control in this type of situation. There's different API calls that are done. Your decisions are dispersed all over the different agents that are interacting via API or the A2A protocol. However, you get some visibility, but it's partial. And the problem that you really get in this type of architecture is scalability scales to complexity. You have all these things, there's so many things going on. It's really hard to have a real visibility of what's going on when you scale this kind of distributed, disconnected type of environment. The last possible architecture, and the one which we're using and promoting here, is orchestrated AI. And this is a model-driven approach where the control is in the executable model. The decisions are very explicit, version and control. You have full observability of the behavior. And when you scale this, you scale towards governance. You have all that you want to a regulated industry. So only one of these approaches really makes AI replaceable without losing control. And this is the idea of bring your own AI so that you can follow the rapid growth and the rapid capability that the different models are getting, and can just basically rip the last one and replace it without changing how things are going. So this is what we're really pushing here today, is this governed type of AI or orchestrated AI. So let's talk a little bit about what kind of architecture we're proposing more in detail here. And we're using something that's called a neurosymbolic architecture. And the neuro part refers to the sensing and the flexibility and adaptability. And the symbolic architecture part refers to the deterministic aspect, where you can guarantee the same results giving the same inputs. So this architecture, we're presenting it here as three layers to abstract it more simply to everybody. But the AI neurosensory layer is providing the interpretation of the context, and it is adaptive. The symbolic layer in the middle is the orchestrator. It provides the guardrail. It ensures business is carried out as per laws and regulation or policies. And then that whole layer should be the same whether your last layer, which is the assistant or agent layer, should be the same whether this is an AI doing it or whether it's a human doing it. So basically, we're getting into a governance kind of situation where you ensure that whether AI is doing the work or your actual personnel, knowledge worker are doing the work, you get the same result. So let's drive a little bit more deeper into the architecture and look at how with Retake we're exploiting what we call a decision-centric orchestration, which has become basically the enterprise control system.
So I'll expand. I'll expand on the points Denis just made, which is true enterprise scale AI mandates the neuro-symbolic architecture we just described, because that architecture provides a single source of truth and the necessary evidence to assure that those operations are correctly executed. So as we talked about that second layer, the integration-led AI, a lot of those things are done in Python or JavaScript or Java or whatnot. But the issue that we've had is that a lot of good business rules and process steps get buried in that kind of language architecture. Whereas every single step along the way in this architecture, whether it's executing a prompt or applying a business rule to a structured record, is traceable, and we can see how it works. So that's why we're saying that really effective AI is reliant on that type of symbolic architecture. So we integrate our AI prompts into the prompt BPM framework, specifically using BPM and DMN, and organizations can create more predictable swivel chair tasks. All right, that approach really replaces the unconstrained prompts like in version 1 with immutable guardrails. Right, every action is versioned in your continuous integration environment, and that allows us to transition from these fragmented, unobservable automation and old style code to completely traceable and continuous audit readiness.
Yeah, and this is really completely different than the traditional or past robotic process automation RPA type of an approach, where you were scripting the movement on the screen, and then if there's a change to the screen, this would collapse very badly. So now we're talking about using very advanced AI to adapt to the environment, adapt to what's going on, and we're scripting in processes and decision how things should happen, so you ensure that your policies and rules are governed.
So, Keith, what we saw in the demonstration was not something that was case specific. There's no specific DMN, BPMN, CMN diagram for the played pre-authorization process. Instead, we are using a basic pattern that's been implemented in the BPM Plus stack. And one of the steps, the high-level step that comes in, when it sees that request that we showed in the Google Workspace prompt request to the agent, it does a plan against what's in there, and it understands the terms of what it needs to do in order to accomplish it. So this kind of departs a bit from the standard process diagramming we have in other agents. So whereas some of the other tools would be drawing a diagram to show you how a pre-authorization using the played approach is used. We're using the large language model to properly create a regulated execution path for that particular case. So, and those capabilities really represent what we have modeled as a knowledge worker's interaction between the agent and the overall context of the work. So the paths are selected, and we have pre-existing processes. Actually, there are over 140 of them that are pre-positioned to execute the proper action based on the specific context, right? And the context we're getting is from that sub-symbolic planning capability. So in case management acts as the strategic map, it's very adaptable, and BPM and DMM serves as the tactical routes for what we observed.
So in different words, we have a case that provides us the adaptive context to deal with the case, whatever the case is. And then we have the large language models that are used to extract intent in the conversation, which are then converted into speech act, which themselves triggers specific decision and specific process to be acted upon.
Yes. Yep. Next one.
So here, the cases basically are defining the context in which the AI may act. The case trigger the processes under explicit condition, the enforce approval, milestone, and policies. Without cases, your agents operate in a stateless type of conditions and don't really know everything that's going on. So the case is what gives you that context to ground your AI agent in. Basically, the case is your operational guardrail. The model defines the context, and you can trigger within that context based on what the intent of the conversation or interaction has been.
So just to explain a little bit further, so that as we saw, the knowledge worker sent in their chat a request to initialize some type of pre-authorization request with the boundaries and conditions that it needs to execute in. And so at that point, the text is handed to by a process to the knowledge worker copilot that creates a plan for accomplishing the requested objective, verify the pre-authorization capabilities of that request of that borrower. So and it is utilizing these pre-packaged capabilities to write emails, to understand what the emails mean, to route the information to the proper process step, and then monitor the context of the ongoing discussion. Everything that's associated with that particular case ends up in our knowledge worker copilot case file. So if there are additional files and email and meeting notes, everything will end up in the same place associated with that case. So we're really going beyond like a single agent. We have actually the ability to launch 2 or 3 or multiple agents depending on the conditions within the case, and those agents self-organize themselves to create the results that we're seeking, right? And all of that is accomplished because we're using a business case approach. Business case does not follow a strict path. It adopts to the conditions of the information in the case file. So, and as we saw in the end, we have this case file. We can ask questions about it, and on top of that, the basic architecture permits an advisor to watch what is happening within the case. It doesn't, and if anything unusual occurs, it'll notify all the stakeholders, this is late, or this looks like some issue is arising with the execution of this case, right? But it doesn't make decisions in and of itself. But so this is one way. And there are multiple ways that we can integrate like thinking models into the occurrence of the business case. So as we mentioned, the Copilot creates a case based on the operational capability layer using predefined cases and process templates. So if you're a customer, you might have a special process that you need to integrate into it, but it's a very simple manner of using the Trisotech BPM plus environment and defining that and connecting it to what we describe as a case, right? So you can add your own pre-existing templates. They're deterministic. They describe exactly what should happen in general. And they're also include these APIs that are reusable and standardized and can be versioned. So the flexibility, where the flexibility comes, is in the small number of customized prompts that you need to write in order to explain what your review process is. But the persistent case context does not change. It acts as a messaging backbone, and all the interactions are logged, versioned, audible, and deployable as a secure, scalable service within your enterprise cloud. Next. So context really turns these interactions into governed execution. Context is what allows us to move from simple chatbots, situational agents, to enterprise AI. And by context, I don't mean a context prompt window. We're talking about the business context, and that business context are all the information and data and files and structured files that are needed to achieve a specific goal and outcome. And that can take place over days or months if necessary.
And that's a
Yeah.
Tom there, that we're not referring to context as in context engineering that is done in AI, but we're referring to the actual business context in which we find ourselves or the system finds itself.
Yeah, in certain situations, as we said, going back to that, every message, right, that's associated with a text is stored into this case file, right? And there's as artifacts come in, like versions of proposals or invoices, right? We version all of that, right? And every state transition is recorded as to why or how that happened. All right, and so going back to what Denis mentioned, then we can take all of that information, all of the messages, files, information, text information, and it becomes a very easy proposition to make some pretty complicated analysis of that information, right? That information, not only like a SQL structured RAG type query, but also are there any observations that the thinking model can make about a particular case that would be useful to the stakeholders. So we're moving past this AI hype and replacing these risky agent tools that we mentioned in the first two architectures with the knowledge worker copilot. We always keep human in the loop, and we always operate within strictly governed cases, right? And using this neuro-symbolic approach, we wrap our modular AI in those BPM plus models, and we have deterministic guardrails that keep that technology flexible. We can handle and plan a huge variety of cases using the training information that's within the large language model. And that architecture keeps that version data to keep a consistent monitoring feedback loop against that control panel or dashboard that we described. So the way the humans interact and always provide audit-ready analysis of what's occurring within a case. So ultimately, what we want to do is trade this isolated situational agents that we see with small diagrams for a true enterprise-grade infrastructure, right? That's going to really reach out and help your knowledge workers with what they need to do and eliminate the meaningless work associated with that. Next.
So In conclusion, the future of enterprise AI is not in autonomous agent, but really in orchestrated intelligence. This architecture consists of 3-layer, a control layer where explicit executable models guide and ensure the deterministic results. Those are versioned and governed, and they're separated from the AI prompts. Then we have a context layer that is the persistence of the case memory, the business case in which we're working right now, and everything that has to do with it, the events, the data, the current state, and have awareness that is visible to the human as well. And then we have that AI layer that is leveraged for what it's really good, and we're using it for the flexibility and adaptability, but maintaining it within bounded tasks and a way to make sure that we have observable inputs and output, and in a way that we can replace the model so we can use bring your own AI type of approach. So the future of enterprise AI is not in autonomous agent, it is in what we call orchestrated intelligence. This is the time where we had questions during the actual live recording. We did answer the question. If you have further questions, please reach out to Tom at tom.debevoise@kw-copilot.ai. And that's it for us today. Thank you very much for joining us. Have a great day.
Thank you.